Hello friends, you are welcome to my YouTube channel MacPM. So this is our next problem on the trusses. So in this question we will apply the method of section. So this is question: determine the forces in the member FH, HG. This is FH and this one is HG and then this one is GI. So we have to find forces in this member and this member. So each load is 10 kN, so loads are given at 10 kN at each upper joint, and all triangles are equilateral with sides 4 meters. So this is 4 meter, this is 4 meter, all sides are 4 meter, and we know that in case of equilateral triangle every angle is 60 degree. So all the angles are 60 degree. So why are we applying method of section here? So you know that when we don't have to find forces in all members, we have to find forces in only few members, then we can apply method of section, because it is very easy. If suppose we try to solve this truss with help of method of joint, then it will take too much time and we have to calculate forces in all the members to arrive at these members. And second thing is that if we cannot start from method of joints, in that case also we try to apply method of sections. And there is a one difference in the method of joint and method of section, that in method of joints all the forces are concurrent. Means suppose we are considering this joint, then all the forces will meet at this joint. But in this case, this force in this member and this member, these three members will not meet at the same point. They are non-concurrent forces. And remember one more thing, that in case of method of section we cannot find the forces in more than three members at once. So this line which is dividing this crossing these three members should not pass through more than three members. So now let's start this question. So first of all, let's find the reaction forces. So this is a hinge joint, hinge support, so there will be two reactions. Suppose this is RA and this is RH, horizontal or vertical. This is roller support, so there will be only one reaction. Suppose this is RO. So if we apply for whole truss sum of all the horizontal forces is equal to 0, then there is only one RH force in horizontal direction, so RH will become 0. And now sum of all the vertical forces will be also 0. So if we apply this, then RA plus RO, these are upward forces, it will balance downward forces. 10 10, so 1 2 3 4 5 6 7, so 10 into 7. So RA plus RO is equal to 70 kilonewton. So from symmetry you can see that RA and RO are at similar distance from all the forces. So from symmetry we can say that RA is equal to RO. So RA is equal to RO is equal to 70 by 2 is equal to 35 kilonewton. Otherwise, if you don't understand symmetry and if you want to calculate, then you can take moment about point A, and sum of all the moments about point A should be 0. In that case you can also find RO. Then after putting the value of RO in equation, this equation, you can find value of RA. Okay. So for further solving this question, we have to divide this truss into two portions. So from where we have to divide, we have to draw a line from the members in which we have to find the forces. So we have to find the forces in FS, then HG and GI. So we have drawn a line through these three members, and now we will divide this truss into two parts. One part is right side of this line and one part is left side of this line. Suppose in this member force is FH, in this member force is FGH, and in this member force is FGI. So three forces are FH, FGH and FGI. We can take the any direction, means we can take FH in this direction or this direction, and if it comes negative then we have to reverse the direction. So and for problem solving we have to take any one portion, either left hand side of this or right hand side portion of this, so to solve the forces. So we will consider only that portion where number of forces are less. So here we can see that there is more forces. There is 1 2 3 4, and here it is only 3 forces, so we will consider left hand side. So now after considering left hand side, so whole truss is in equilibrium, so either left hand side or right hand side, both the portions will be in equilibrium too. So I have drawn the left hand side of this section. This portion I have drawn here for problem solving, and now let's solve this. So in this portion also it is in equilibrium, so sum of all the vertical forces should be 0. So what are the vertical forces? You can see here 35 kilonewton is upward, so 35, and we will subtract downward forces minus 10 into 3. There are 3 forces of 10 kilonewton, and there is another vertical force which is the component of this FGH. So there will be 2 components, FGH cos theta in horizontal direction and FGH sin theta in vertical direction. So it will be minus FGH sin 60. So sin 60 is root 3 by 2. Okay, so this is equal to 0. So we will find 5 is equal to FGH into 0.866. Value of root 3 by 2 is 0.866. So we will get FGH is equal to 5 upon 0.866. So if we divide this, then you will get 5.7735 kilonewton. So this is coming positive, so our direction is okay. And you can see that if at joint G, from this figure you can see that at point G it is in this direction, so at point H joint H it will be in this direction, so it is outward forces, so it will be compressive force. It is compressive force, because you have to remember, if internal force is like this, then it is compressive, and if it internal force is like this, then it is tensile. Okay, so we have found one force. Now we will do sum of all horizontal forces equal to 0. So what are the horizontal forces? See, one horizontal force is FFH, so we'll write FFH. Suppose this direction is positive, then FFH is equal minus this FGI minus, there will plus its horizontal component will be in this direction, it will be FGH into cos 60. So cos 60 will be 1 by 2. Okay, so we can write here FFH minus FGI is equal to, this will be 0. So FGH we already know, 5.7735 divided by 2. Okay, so we will have, so it will become 2.88675. so FFH minus FGI is equal to 2.88675. so suppose this is equation 1. Now we will take moment about G is equal to 0. Sum of all the moments about G will be 0, because it's a pin joint, so we can take moment about this point is equal to 0. The sum of all the moments about G is equal to 0. So we will write, see, this is 4 4 4, and if we draw the line from this action of force of this force, then it will be 2, and this will be 2. It will divide equally into this base. So we will write 35 into, see, what is the distance, 4 plus 4 plus 4 is equal to 12. This is clockwise. Suppose we are considering clockwise as positive, then minus, due to this force, 10 into distance is 4 plus 4 plus 2. This is counterclockwise, plus 10 due to this 4 plus 2 is equal to 6. Sorry, this will be also minus because it is counterclockwise, and due to this minus 10 into 2, and due to this FFH, force will be also negative, moment will be negative counterclockwise. FFH into distance is, this is 4 meter, this is 4 meter, this is 2 meter, so this will be root 4 square minus 2 square, so it will become root 16 minus 4, so it will become root 12, or we can write is 2 root 3. Okay, now we will write here 2 root 3. Sorry, I have done a mistake here. See, we have write 35 into 4 plus 4 plus 4 from here is equal to 12 minus 10 into, this is 2 meter plus 4, 6 plus 4 is equal to 10. So we should write here 10 minus this 10 into 2 plus 4 is equal to 6 minus this 10 into this distance is 2. Okay, so this is 2 root 3. So if we solve this, then we will get 35 into 12 is equal to 420 minus 100 minus 60 minus 20 is equal to, this is FFH, this is equal to 0, so FFH into 2 root 3, so it will become 420 minus 180 divided by 2 root 3 is equal to FFH, so it will become 240 divided by 2 root 3, or you can write 120 divided by root 3. So if you will find its value, then it will come, so it will become 69.282 kilonewton. It is also positive, so direction is okay. So we can write FFH in this direction, so it will be in this direction here, equal in the opposite, so it is outward force, so it is compressive force, so it will be compressive force. Now we can find FGI. FGI is equal to FFH minus 2.88675, so we can write its value as, FFI will become, FGI is FFH, sorry, it was positive here, this was minus, and this was plus here, so if it will go on this side, so opposite side of 0, it will become minus, so this was minus here, so it will become plus, so 69.282 plus 2.88675, so it will become 72.1688 kilonewton. And you can see the direction of FFI is, FGI is outward, and here it will be in this direction, so it is inward force, so it is tensile force. I hope you got this, how to solve the method of section for a truss. If you don't understand any point, then please ask in the comment section, and thanks for watching this video. If you like, then please subscribe this channel and share this video. Thanks for watching.